On industrial automation of BMC machine using the PLC control system. Basically, BMC mean biomedical component machine. Okay, so this biomedical component machine is developed for the purpose of the biomedical components machines, and in which I have just added the introduction for the project BMC machine. It's PLC configuration, like how we will develop the PLC complete section for the PLC control system. Its project background, machine overview and specification. This is the machine overview in which the circular track is added in this section, and the vertical movement section, this is the vertical movement section, and the control box added in this machine. Okay, so next part is basically it also, this is the limit switch, basically controlled for the movement of the board from its automation. Okay, the maximum speed of RPM is 150 RPM to throughput with mechanical safety limits, and its 0.1 degree resolution ensured the high positional accuracy. So this machine operates at 220 volt VAC, a 50 hertz supply, and it will use the PLC motor drivers, power supplies, as well as the safety relays. The hardware design is that I have used basically Siemens PLC to develop the complete BMC machine for to control its automation functions basically. And this is the control system for the BMC machine. Control box which user can interact and user can select its input. Like this control box will take the input from users and it perform the actions based on the user input. So this will the PLC control system in which we have just developed the complete PLC section, which contains the breakers, relays, PLC sections, I2C communication modules, as well as Ethernet modules, and the power drives, electric drives. So this is the user interaction mode in which RDY buttons, STB, ALM, STR, STP, and on off button. Basically, it also contains the ready indicator, stop, standby indicator, alarm indicator, start button, stop button, on off selector. All the functions of this complete machine are added in this table as well. Okay, and this is the electrical control block diagram which I have developed for the control of say different motors, different its safety contacts, and power supply from Siemens PLC, IoT modules, circuit breaker, magnetic contactor, emergency IO expander like input output modules, input output expander, and safety contacts, outer deck motor, inner deck motor, takeoff motor. And next one is the software and programming. In this section basically I have used the set positions, read position, set velocity, and set start motion basically of the machine. Through the user can input through PC side, as well as where the received acknowledge or error message from the PLC was recorded within the timestamp. Basically, it also uh, monitor the event management through every event in the PC. Okay, so this is the software module, software testing for the BMC machine, in which two motors added in it. Pulse control system is added with the Siemens PLC used for TCP/IP, and the IoT device for the Siemens PLC used, and ladder logic PLC programming is used in this section, and the laptop is section is used to remote and console the run the console section basically. And in the PC interface, via I have just explained like how the PC interface with internet modules through TCP, Modbus TCP protocol for communication purposes, and SCADA systems as well. So next part is the control parameters, acceleration, position, and velocity. For the acceleration, position, and velocity, we are using the electric drives for different motors, which controls the speed of the motor. It's to control its position control system for the motors, and all the changes through with the user interaction. Like user can set the speed, its position, its velocity as well. Okay, and next part is the safety and reliability considerations. Okay, the safety is one of the most important factor for this complete biomedical machine, compact machine, and we are using IP54 standards to protect against dust, accidental water splashes, as well as the failure mode effect analysis as well. Okay, next part is the testing and performance result. Basically, this machine provide us one of the best performance in terms of accuracy, like 97% its accuracy are very good. So we have used in our industrial challenges, industrial automation. Basically, we have this section provide us the challenges faced solution implementation, in which we have faced different challenges like PID parameters to control the servo motors, to control the shoppers, lead screws, as well as the smooth motion control at both low and high speed without resonance issues basically. So I have added its conclusion and the complete references accordingly. Okay. So let me just show you the project file. These are the project files, BMC machine for the PLC machine. Like all the PLC machine are added in it, different kinds of its logs, its complete project files, and controllers and motors are added in terms of uh, uh, hardware as well. And the, like for example, this one is the error find out in during the designing of the machine. This is the limit switches, this is electric drives, and all the screenshots taken and mechanism description are added in it. Let me just also check the Python code which I have developed for IoT code like BMC machine testing. Like these are the Python code used for the BMC machine to control its automation through different position, through different options basically. Okay, input and output devices. All the configuration added in this section, you can just read it accordingly, and the snap types and everything added in it. Okay, I think it is okay now. Thank you. If you need to ask anything, you can ask me. Okay, thank you.